Hi, geometry classes. This is the circle unit part 2. So today we're going to look at lesson 8, which is the equation of a circle. Remember our definition of a circle back from the beginning of this chapter, and that's a set of all points equidistant from a given point. Now we're actually going to be talking about what that equation of a circle looks like. Because just like with lines and parabolas, the equations look a certain way, so do the equations of circles. So the first one that we're going to look at is an equation of a circle that has a center at the origin. So as you know, the origin is right here in the middle, 0, 0. So if we look at this, is just a portion of the circle that we have graphed in exercise 1. The center is the origin, and the radius is 10. So we're going to answer the following questions. What is true about every point that lies on the circle? So this point up here that I'm drawing, we can actually count. It's 10 away, all right? And this point over here on the x-axis, we can count. That's 10 away. Now the other ones I can't necessarily count because they're not a vertical or horizontal line, but every single point on this circle, no matter where it is, has to be the same distance away, and that distance away is going to be the radius. So it's the same distance from the center. Okay? Now next I want to algebraically show that the point 6, 8 must lie on the circle. So I'm going to do that by drawing myself a triangle. Okay, so again, pretending that like this is the origin of the circle, and this was 6, and this was 8. Okay, if I wanted to find the length of this line right here, okay, so, and actually let me do this. So if this point right here was 6, 8, okay, so this was 0, 0, that's the origin. I want to show that that point 6, 8 is on the circle. All right, so that means that I am 6 away from, counting on that bottom line, and 8 up, counting on that top line. So the radius would have to be 10, okay, because we know in my circle right here that the radius is 10. So every single point must be 10 away. So the point 6, 8 also must be 10 away. All right, so let's check it out. To know that if this was true, I'd be using the Pythagorean theorem. So 6 squared plus 8 squared equals 10 squared. Well, let's see if that's true. 6 squared is 36, 8 squared is 64, and 10 squared is 100. Okay, yeah, 6, 7, 8, 9. What did I do? Yep, we're good. So 36 plus 64 is 100. All right, so this is true. So the point 6, 8 does lie on the circle. Now it looks like the point 7, 7 also lies on the circle. Let's see if it does. Well, again, we would just test it out. If the point 7, 7, it has to have a radius of 10, but let's see if 7, 7 lies on the circle. 7 squared plus 7 squared equals 10 squared. 49 plus 49 equals 100. 98 does not equal 100, so it does not. I mean, it certainly looked like it did if I was looking at the point 7, 7, okay, but it does not lie on the circle. If the point xy lies on the circle, let's write an equation that would be true. So just like we did before, all right, so if any point xy lies on the circle, it has to have a radius of 10, and it would be x squared plus y squared equals 10 squared. All right, so this is going to be our format for an equation of a circle. So equations of circles centered at the origin, right, I'm looking right here in the box, are going to be x squared plus y squared equals r squared. And r is going to represent the radius. All right, so let's look at exercise 2. The point 7, 4 lies in a circle centered at the origin. Write the equation of the circle and state the radius. So if the point 7, 4, okay, lies on a circle, I want to find this radius right here. We need to find the radius because I can't write the equation of a circle without the radius. And this is important that they're centered at the origin. I'll show you a little bit later how to do it when it's not centered at the origin. But again, this is my origin 0, 0. This is my point 7, 4. And I'm trying to find out the radius. I'm trying to find out this line right here. What is the radius of my circle? So I'm going to do my Pythagorean theorem. 7 squared plus 4 squared equals r squared. 49 plus 16 equals r squared. 65 equals r squared. So r equals the square root of 65. Okay, now to write the equation of the circle, all I need is that radius. So the equation of a circle is going to be x squared plus y squared equals the square root of 65, because that's my radius squared. I'm using that equation that I have highlighted up above. X squared plus y squared equals r squared, and r happens to be the square root of 65. Well, the square root of 65 squared is just going to be 65. So x squared plus y squared equals 65. And that's my answer. Now, if I want to test out to see if the point -8, 1 also lies on this circle, I would just plug it into my equation. So I'm going to take my equation, x squared plus y squared equals 65, and I'm going to plug in -8 for x, and I'm going to plug in 1 for y. And if this works, then the point lies on the circle. And it does, in fact, work. Because -8 squared is positive 64, and 64 plus 1 is 65. So yes, that point lies on the circle. Okay? All right, let me show you how to graph, because graphing is super simple. So the center of the circle is the origin, 0, 0. Now this number right here, the 25, is my radius squared, because remember, x squared plus y squared equals r squared is the equation of a circle. So if the radius squared equals 25, then the radius is the square root of 25, and the radius is 5. Okay, now look how easy this is to graph. So I go to my center, 0, 0, and I just go 5 to the right, 5 up, 5 to the left, because my radius is 5, and 5 down. And then I just connect them, and I make it look as much like a circle as I can. If you had a compass, you could do this a little bit better. And there I go. So to graph an equation of a circle, you just need 2 things, the center and the radius. It's nice and easy. All right, let's look at a circle that's not at the origin. This circle is centered at 2, 3, right here, okay, and has a radius of 5, and I can count 1, 2, 3, 4, 5. So I can confirm that, yes, in fact, that radius is 5. Is this circle congruent to the circle that we did up above? What do you think? Well, yeah, they both have the same radius of 5. So yes, they are congruent. Both have a radius of 5. Now, to be congruent, there has to be a sequence of rigid motions that maps one onto the other. So is there a sequence of basic rigid motions, so either a rotation, a reflection, a translation, that would take this circle and map it back onto the circle above that has its center at the origin? And yeah, I'm not rotating it, I'm not reflecting it, I'm translating, I'm going to shift it. So a translation, and I would have to bring it, let me get a different color right here. All right, so I would have to shift it over 2 and down 3. And that would bring that point back down to the origin. So a translation of -2, -3 would shift that back to the origin. So here's how the equation looks. So the same pattern that I had up before, but the equation of this circle is x minus 2 squared plus y minus 3 squared equals, and again, my radius is 5, so 5 squared is 25. So it's similar to the one they had before, but I have to put that translation. So the shift that I'm doing left-right, that number goes next to the x, and the shift that I do up-down, that number has to go next to the y. All right, but let's think about what our center was. Remember, the center of that circle was +2, +3, but look at my equation. When I write it in my equation, the signs are the opposite. So just keep that in mind. So this right here is the equation of a circle. All right. So it's going to be x minus a squared plus y minus b squared equals r squared. Keep in mind the center is positive a, positive b, but when I write it in my equation, I am doing the opposite sign. And then the r squared is on the right, just like it was before. Okay, so let's write that down. The center is the opposite signs of the equation. Okay, so let's look at a few. Let's write the equation of the circle that's graphed below. So the center is negative 2, 4. Okay, I can see that right here. Let's look at what my radius is. Oh, my radius just has a radius of 2. Okay, so writing that equation, so it's going to be x plus 2 squared plus y minus 4. So remember, these numbers right here are going next to the x and the y, but the signs are going to be the opposite, equals, and my radius is 2. 2 squared is 4. There we go. All right. Find the radius and center of the circle given by the equation x plus 12 squared plus y minus 4 squared equals 81. Well, the numbers that give me the center are the numbers that are next to the x and the y, but I do have to do the opposite sign, so it's going to be negative 12, positive 4. And this number on the right is the radius squared, so the radius is the square root of 81, which is 9. Okay? Let's write an equation for a circle whose center is at 9, 0 and has a radius of 7. So these numbers go next to the x and the y. So x minus 9, I got to do that opposite sign there. Now y minus 0, I certainly can write that, but I don't have to. And my radius is 7. 7 squared is 49. Done. So circle equations are pretty easy. All right, last one right here. So 2 points in the plane. A is negative 3, 8, and B is 7, 18. They represent the endpoints of the diameter of the circle. I want to find the center of the circle. So this is what I have just so you can visualize it. A and B, okay? Those are the endpoints of the diameter of the circle. Now to write an equation of the circle, I need to find that midpoint. So that's the first thing I'm going to do. The center of the circle will just be the midpoint. So I'm going to add the x's and divide by 2 and add the y's and divide by 2. So I'm finding the center of my circle. Well, that's 14 over 2, which is 7. 8 plus 8 is 16 over 2, which is 8. So there we go. Now I have the center of my circle. Now I want to find the radius of my circle. So the radius of my circle is the distance from the center, which I just found, to the end point. So I know my center is 7, 8, and I know that point B right here is 17, 8. So I have to find, if I want to find the length of the radius, then I'm going to have to use my distance formula. So I'm going to find the distance between the center, which is 7, 8, and the end point, which is 17, 8. So this is my center, this is my end point, and I'll use my distance formula to do that. So everything that we learned in that last chapter we're using right here. So I subtract the x's, 17 minus 7, and then I subtract my y's, 8 minus 8. So 17 minus 7 is 10. 8 minus 8 is just 0. 10 squared is 100, and the square root of 100 is 10. So now I know the radius. The radius equals 10. So this is my center. This is my radius. Those are the two things that I needed. Now I can write my equation of a circle. So the equation of a circle is going to be x minus 7. Remember, you're doing the opposite signs there. Squared plus y minus 8 squared equals the radius squared, and 10 squared is 100. right? So that one definitely was a little bit more involved because I had to find the center and I have to find the radius. Now, what if I have numbers? I said that was the last one. I forgot there was one more. What if I have numbers in front of the x and the y? I have to get rid of those numbers. So I would just divide everything by 5. And I have x squared plus y squared equals 36. So 180 divided by 5 is 36. Now I can find my center. My center is just 0, 0. And remember, the number on the right is the radius squared, so my radius is the square root of 36, which is 6. Alrighty? And we will practice those tomorrow in class.